Well, hello again, everyone. Hope that you're all doing well. We're enjoying another day learning from home, but here's a lesson. The first hour of our double, I really want you to focus in on error in measurement, and that you would have done yesterday. Hopefully, you need to get that clear. And then this one, it'll probably take you less time to revision some aspects of things that are new, but we need to keep moving. So we're talking about perimeter. We're starting the other part of measurement, which is the perimeter, area, and volume. This is chapter 5. And so the perimeter is the distance around the outside edges of a figure. All right, so whatever the figure is, triangle, circle, rectangle, ellipse, combination of any type of figure, it's just the distance around the outside. And of course, for a circle, it's got a special name, which is the circumference. So best illustrated by just jumping in and doing a few examples. So let's do the first one. We have a rectangle here. That side's equal to that, that side's equal to that. The perimeter, often given by the letter P, makes sense, is going to be, now you notice what you do need to take care of is that the units are the same. We've got millimeters and centimeters here. So in one sense, I could write 45 millimeters plus 45 millimeters because that's the other side. Both of them are there. It's all the way around. Plus 2.1 centimeters plus 2.1 centimeters. But I can't do the actual sum. I can't do the actual sum until the units are the same. And so, well, we've got a decision to make. Whether we're going to do it in millimeters or centimeters. Let's do it in centimeters. So I'm going to change the millimeters to centimeters, which we divide by 10, all right? Because we're going from a small unit to a larger unit, we divide. There's 10 millimeters in a centimeter, so that becomes 4.5 plus 4.5 plus 2.1 plus 2.1. That gives me 9 plus 4.2, 13.2 centimeters. Now, if you wanted to, of course, you could, it's equal to 132 millimeters. Either way, that's okay. Depends what the question asks, context of the problem, whatever it might be. Okay, let's go have a look at the next one. Here we have a right-angled triangle. A right-angled triangle. Put a bit of space in here because I think we're going to have to. And we need to remember something about right-angled triangles, and that is Pythagoras' theorem. We've been doing that since year 8. Of course, we have a squared, b squared, and c squared, a, b, c. If you have a right-angled triangle, c squared is equal to a squared plus b squared. Now, another way to express that is to say, well, a squared, for instance, would be equal to c squared minus b squared, the difference. So if you take the longest side here, which in this case is c, and square it and subtract a or b, then you get the third one. All right, so that's Pythagoras' theorem. I'll just put Pythag. So that applies here to this one, because this side here, we don't know what it is. This one we don't know. And if we want to find the perimeter, then how am I going to find it without that side? So let's call that x. Let's call that x. So basically, Pythagoras' theorem tells me that 10 squared is equal to 6 squared plus this unknown side, x squared. But I could have just jumped in and done it the other way. So I can say x squared is equal to 10 squared minus 6 squared. The longest side squared minus the other one. Now that's equal to 100 minus 36, which is equal to 64. Right, so x squared is equal to 64. Now to undo the square, we do the square root. X is equal to the square root of 64, which is equal to 8. So I can write that in over here. So now, therefore, 3 dots, therefore, the perimeter of this triangle is equal to 10 plus 6 plus 8, which is 24 centimeters. All right, there's a few questions like that. Obviously, Pythagoras' theorem in this course is a necessary topic, and we need to be across it well so that we're not messing it around. And if you need to go back, MathSpace is a great place. You can ask me about it. We can go back and do some questions on it, whatever you like. But you need to be clear. So there's some questions where you've got compound figures where things are stuck together. So have a look and see how you go with it. But the perimeter, sometimes we have to find missing sides using the sort of logic that we need. Okay, let's jump to the next example. Here we have a circle. Okay, here we have a circle. Now, this measurement, 85, of course, we call the diameter. Diameter is equal to 85 millimeters. 85 millimeters. All right. Now, at this point, you could change it to centimeters, but I might do that at the end just to see what the final number is. So the diameter is equal to 85 millimeters. Now, that means that the radius is equal to 85 divided by 2, which in this case would be 42.5 millimeters. Now, why is that important? Because usually the radius is important. The radius is necessary. Well, to find the circumference, you can use the radius, but also to find the area, we'd need the radius. So down the track, when we do area, we're going to need that as well. So we have the radius. So C for circumference is equal to pi times the diameter, or 2 times pi times the radius. It's the same thing. Pi times the diameter, or 2 times pi times the radius. So we've got the diameter, so that's nice and simple in our case. So in this case, C is equal to pi times 85, which is equal to, well, pi is 3.1415. If you have your calculator handy in front of you, maybe a good opportunity to make sure you know where pi is, and to do that. But according to my calculator, this gives me 267.03537.... Now, I wrote it to all those decimal places. It's a good habit to get into. When you get a calculated answer, write it out to a number of decimal places and then round it in the next step. So I'm just going to go to the nearest millimeter, 267 millimeters, which is equal to 26.7 centimeters. Probably a slightly better unit, more sensible if you like. So if you have an 85 millimeter diameter, it's just pi times the diameter, gives you 267. All right. So we've got that, and that's kind of circles. So of course, you're going to have all kinds of bits of circles as well. If I want half the circumference, then I will just divide by 2. If I want a quarter of the circumference, I'll just divide by 4. And then if it's maybe stuck on to something, we can calculate that as well. But the key thing is we need the radius or the diameter, and then we use the proportion of the circumference or the full circumference that we have. And that leads us to the final question or final example that I'm going to do, which is this one. So this is our perimeter. So we're going to have to find 3 sections. We're going to have to find the curved part. This is only part of the circle. So we got that. Then we have this. This is the center of the circle. Imagine if... Hang on. Excuse me. Imagine if the circle kept going. That would be the center, right? But we only have what's called... This is a sector, if you remember your circle stuff. This is a sector of a circle. Kind of like a piece of pie. And so if we kept going, and so this is actually the radius. And notice the sign. So this also is 5.3 centimeters. So the circumference we have to include, not the circumference, sorry, the perimeter of this figure. We have to include that, we have to include that, and we have to include the curved side. 3 things. And so the first one to find is the curved side. Now, this is part of a circumference, yeah? This is part of the circumference, but how much of the part? And the clue is in this 45 degrees. So 45 out of 360. Okay, so it's 45 degrees out of 360 degrees worth of the circumference. And that's a fraction problem. If I know I have 45 degrees out of 360 worth of the circumference, then I need to work that out. So the proportion, another way to say it would be the proportion, is equal to 45 over 360, and that's equal to 1/8. And this would apply for all those kind of things. So if I wanted to find, and this is called an arc, by the way, the outside of my sector, or the part of a circumference, is called an arc. Let me write that in red. Part of a circumference is an arc. Not a K though, it's not that kind of arc. With all this rain we could have used it, but it's an ARC arc. So 1/8. So the arc length is equal to 1/8. That's the proportion of the circumference multiplied. So 1/8 of, and of is used by multiplication, 2 pi r, which we saw before, which is 2 times pi times 5.3 in this case. That's my radius. And so if I work that out, we're going to get, let's see how we go, 1/8 times 2 times pi times 5.3 gives me 4.1626 ... And that's in centimeters. And I'm just going to go, because the other measurements are to 1 decimal place, I'm just going to go to 1 decimal place as well. 4.2 centimeters to 1 decimal place. Now I've got the arc length. I can just find the perimeter, which is equal to the 3 sides added together. 4.2 plus 5.3 plus 5.3, which is equal to 10.6 plus 4.2 is 14.8 centimeters is my perimeter. So there we have it. We've worked it out. So look at the key steps. Work out the arc length by using the angle inside, finding the proportion of the full 360 degrees. 360 degrees is a full circle, that's why. We find that proportion, then you multiply that by the circumference, 2 pi r times, in this case, 1/8. Work that out, and then we add it on to whatever other sides we have as part of the circumference. So we've got a few questions going, so we want you to have a go, or I want you to have a go. Exercise 5A, again, focus for today, spend half the time on error, continuing that work, and then we can get into this. All right, stay safe, stay dry, have a great day. Bye.